So we're into chapter 6, and we're going to be working on a random variable. So let's first answer the question, what is a random variable? Well, a random variable is a numerical outcome, and it should say from a probability experiment. I just realized I don't have my font large enough here, so hold on one second. Let me change this up to 16. Boom, much easier to see. So it's a random variable is a numerical outcome from a probability experiment. Now, I've had other ways to describe this, and so I'm just going to, throw these out here and sort of see if it just sort of lands well. So a random variable is a response. It's a numerical response to an experiment that has chance involved. So I need to put in here numerical response to an experiment that has chance involved. Okay. So for instance, rolling a die has chance involved, and there are 6 outcomes. And if you look at this table here, you'll see that this is actually a probability distribution. And we talked about this in a previous video, but the probability distribution has each of the probabilities between 0 and 1. Could include 0, could include 1, but neither or none of these do. And if you add all these up, you're going to get 1. So 1/6 plus 1/6 plus 1/6 and so on is going to add to 1. The numerical values that are the outcomes, you could roll a 1, you could roll a 2, you could roll a 3, you could roll a 4, a 5, or a 6. So the random variable x represents the outcome from the roll of the die. And this is the probability of the outcome. Now, going back for a minute here, I'm emphasizing that these have to add to 1, and each of these values have to be between 0 and 1 inclusively. So if you saw a table that looked like this, and I will duplicate this, and you had here instead 2/6, and all of these are 1/6, this would not be a probability distribution because the sum is greater than 1. If this was a negative 1/6 and then this was a 2/6, still a problem. It wouldn't be a probability distribution, not because they don't add up to 1. Actually, I think I need, so we have 2, 3, 4, 5, 6, and then that we'd have to do this 3, 6. So just check me on there. So 2, negative 1, and 3 gets me 2, 3, 4, 5, 6. So it's sum to 1 in this instance, but because one of the probabilities is less than 0, it's not a probability distribution. All right, let me delete that. And we will do a quick draw of the histogram, the relative frequency histogram that is connected with this probability distribution. So here is going to be our P of x. That's the side there. And then here is our x that could occur. And the title that I'd give this, and remember we always have to give it a title, would be the relative frequency histogram of the probabilities of the roll of a die. And so our responses are 1, 2, 3, 4, 5, and 6. And since all of these have the height of 1/6, I can draw my bars to be the height of 1/6. But notice that's a histogram, so I have to make the bars touch. So my class boundaries go at the half marks. So, this is 0.5, this is 1.5, this is 1.5 to 2.5, 2.5 to 3.5, 3.5 to 4.5, 4.5 to 5.5, and 5.5 to 6.5. All of those are at the 0.5 marks, and the edges of the bars share the same and so the bars touch. Okay. Um, this distribution is uniform. We talked about those briefly previously. Um, as a, let me do the following. I think I can get this just to delete. Yep. Good. 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 Should be able to click on that. Click on those, and they're gone. Good deal. Okay. So now we're going to talk about the mean and the variance and the standard deviation from a probability distribution. And you do need to note, I didn't say this earlier, this is a discrete probability distribution. These values aren't continuous, so 1 is the only value that you're getting, or 2 or 3 or 4 or 5 or 6. We're not able to get 1.1 or 1.2 or 1.3. When you're dealing with continuous random variables, you work with intervals. When you're dealing with discrete random variables, you're dealing with specific values like 1, 2, 3, 4, 5, 6. Depending on how this is set up, you could have like a 1.5, a 2.5, but those are specific values rather than an interval. Now, let me write in here the mean of a probability distribution is going to be the sum of each of the data points multiplied by the probability of that data point. So what's going to happen here is if we're trying to find the mean of this probability distribution, we're going to have 1, which is our first x, multiplied by 1 over 6, and then plus. So the summation is giving us the plus. This piece is giving us the 1, and this piece is giving us the 1/6. Now, our second data point is 2, or our second response is 2, and that's going to be multiplied by 1/6. And then we're going to have 3 multiplied by 1/6. And I'm running out of space, so I need to kind of squish this, but I hope you see where the numbers are coming from. Then 4 times 1/6, and then plus 5 times 1/6, and then finally plus 6 multiplied by 1/6. So what ends up happening is if we punch that into the calculator, what the calculator will do is they'll have 1/6 plus 2/6. And just a brief comment, when you multiply a whole number times a fraction, you put the whole number over 1, and then you just multiply straight across. So the top 1 times 1 gets us a 1, the 1 times the 6 gets us a 6. It's going to be 2 times 1, and then 1 times 6. So this is going to be plus 3 over 6, plus 4 over 6, plus 5 over 6, and then finally plus, and that's supposed to be a plus, 6 over 6. All right, well, the denominator, because when you add fractions, you keep the denominator the same, and you go 6 plus 5 plus 4 plus 3 plus 2 plus 1. Well, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21. So we have 21 divided by 6. Now, I don't have the exact decimal in front of me, so just give me 2 seconds to punch that into my handy-dandy graphing calculator. So 21 divided by 6. And we end up with 3.5. Okay? So our mean is going to be 3.5. Now, our standard deviation, let me see if I can convert to the other form here. And remember, the two ideas that our predominantly present in statistics are the measure of the center, which is often the mean, sometimes the median, sometimes the mode, and we often talk about the spread of data. So I did make the comment that our relationship to variance and standard deviation is one is the square root of the other. So our variance, the formula for the variance is going to be, variance is sigma squared, which is going to be the sum of each data point, each data point, I need to erase that, I want that gone. Each data point, but each data point is each random variable, and then we are going to subtract the mean, and then we are going to multiply, or square that, sorry, and then we're going to multiply it by the probability of that data point. And the relationship between the variance and standard deviation is when we take the square root of this thing, then what we get. So that formula that you see right here is going to go inside that square root, and when you do that, you get your standard deviation. That still remains the same. But to clear out some space, I need to do some erasing, so forgive me. All right. So I'll say it this way. Suppose I erase the 2, and then I say, oh, now I'm looking for the standard deviation. I put the square root over that. But variance is what's inside. So here we go. We're going to take 1 minus 3.5 squared, and the probability of the 1 is 1/6. And then the summation tells us to add. So the next one will be 2 minus 3.5 squared times 1/6, and then plus 3 minus 3.5 squared times 1/6. And now I'm going to have to go down a line here, so forgive me. 4 minus 3.5 squared times 1/6, and then plus 5 minus 3.5 squared plus, and then last 6 minus 0.5 squared times 1/6. I do have a typo I just caught. This paren doesn't need to be there, so I need to erase that. So, all right. This is going to be negative 2.5, and we're going to square that. So if I take 2.5 and I square that, so 2.5 raised to the second power, it's negative 2.5, and you square it, because it's a negative and you're squaring it, you're going to get a positive 6.25. And then that's multiplied by 1/6. And now we have 1.5, negative 1.5 squared, which will be 2.25, and then times 1/6. And then finally 0.5, and 0.5 squared is 0.25, so we have 0.25 times 1/6. Okay, we're going to add on to that. So this is also going to be a 0.25 because it's 0.5 squared. Even though it's not negative, the negative you squared, you're going to get 0.25. So we have another 0.25. Forgive me, I don't know why I did that. Let me go back and get this back to drawing. There we go. So 0.25 times times 1/6. Doggone it, I don't know why it's doing that. So stop doing that. 1/6. I have a hunch I need to scroll that up. There we go. That probably will stop it. And then we're going to have 1.5 squared. And so we end up with, again, 2.25 multiplied by 1/6. And then finally, we're going to have 2.5 squared, which is the same as here, except this is negative. But again, when you square a negative, you get a positive. So we've got 6.25 times 1/6. Now you can factor out the 1/6 and put that outside of the parentheses, and you're going to add 6.25 plus 2.25 plus 0.25 plus 6.25, 2.25, and then 0.25. Let me crunch that in real quick. So 6.25 plus 2.25 plus 0.25 plus 0.25 plus 2.25 plus 6.25, and we get 17.5. So in here is a total of 17.5. Then so 17.5 divided by 6, and we get 2.9. I hope I didn't add anything wrong. So 2.91666 keeps going. So 2.916 repeating. That is our variance. And then when we take the square root of 2.916 repeating, so second square root, where's my square root? There it is. And we get 1.707 as the standard deviation. So remember, the 2.916 is the variance, and the result of this, which is about 1.7, is your standard deviation. I'm going to do one thing real quick and make sure I didn't mess anything up here, but just to make sure. So 2.5 raised to the second power, 6.25, 1.5 raised to the second power, 2.25, good. 0.5 raised to the second power is 0.25. Good deal. So it looks like I crunched that out okay. Hopefully that makes sense, what we just talked about. If you have any specific questions, feel free to reach out. We'll do some more examples tomorrow for videos, and then we will get into the binomial distribution. All right. You have a good day.